working, but I guess I can take it off. Anyway, this is for the test review for tomorrow. This is the review, and we have graph 1, 2, and 3 here. I've already created the tables here, here, and here for this graph to appear on Desmo so that I can get these points. Graph 1, the domain. So for the domain, as long as there are no endpoints, the domain is all real numbers for all 3 of them. All real numbers and all real numbers. And then the range is contingent upon the vertex. So the vertex I'm going to skip to, and this would be about -1/2 and -5.5. -1/2, -11/2. That's 5.5. This one would be 0, 1, 2, 3, 4, 5, 6, 7, 8. And this one over here would be 3, -9. Now I can write my range. So my range is contingent upon, like I said, the y value. Range, y, y, y. And it'll be y is, because this opens up, it has a minimum. And this will be y is greater than or equal to -11/2 or -5.5. And then over here, this opens down, so its y is less than or equal to 8. And then over here, this is opening up, so y is greater than or equal to -9. This has a minimum, this has a maximum, and this has a minimum. Remember, the minimum values are at the y-axis. At y equals, at y equals, at y equals. This also comes from the vertex, so this will be -5.5. This will be 8, and this will be -9. My axis of symmetry is also derived from the vertex. Axis of symmetry is the green. So x equals -1/2 or -0.5. X equals 0. X equals 3. That's how we determine those. The zeros are where it crosses the x-axis. That is something that we have to remember for quadratics and even for linear functions. The zeros, because it will ask you about a zero, and that's where we have to look here, here, and here. So the zeros here are -2 and 1. X equals -2 and 1. They should be written like that, not a coordinate pair, unless it asks for the x-intercept. Then it would be -2, 0, 1, 0. X-intercepts. This one has x-intercepts at -4, 0, and 4, 0. -4 and +4. And this one has x-intercepts at the origin and at 6. X equals 0 and 6. And then the coordinate pairs for that are -4, 0, 4, 0, 0, 0, 6, 0. Know the difference between listing the zeros and listing the x-intercepts. The x-intercepts are coordinate pairs. The zeros are just the x values. All right, and list 3 points on the graph. That comes straight from the table, straight from the table, and straight from the table. Write this function in standard form. So in order to do this, we must square this. X plus 7 gets squared. minus 6. I guess we don't need Desmos. I did want to show you how to determine your axis of symmetry really quick. So for this first table, I'm going to turn this one on and this one on. Okay, turn on two things. Let's turn those off. And then for my axis of symmetry, which one was this one? This does not look like any of the ones that I wrote. -2, 0, -5, -0.5.5, and then 1, 0. That's not what I have here. Oh, let's turn this one off. And let's turn this one on. There we go. And then when I type in my axis of symmetry, it was x equals -0.5. It should cut right through that vertex right there. And then the same thing for the other one. I'm going to clear this one out. Bye-bye. And then this next axis of symmetry is x equals 0, 0. And then I'm going to turn these points on. Nope, that's not the one. I don't know which one this is. 0, 0, -3, -9. Oh, that should have been x equals 3. My bad. And I can't have a -0. X equals 3. Turn this on. Turn this on. There we go. It should cut right through your vertex and split your parabola in half. So we're going to cut that out. Cut that out. And then this one right here. This should be -4. 0, 0, 8, and 4, 0. Now it's making sense. And then my axis of symmetry is x equals 0. And let's change the color to make it look, to make it stand out. Let's make it orange. And let's dot it. Let's make it a little bold. Let's see how thick that gets. Not that thick, but you can see that it's not a black y-axis anymore because it cuts right through x equals 0. So that's what the axis of symmetry should do. Alright, so over here on this one, we are going to square this. And you know what? I would just put this in Desmos to see who's equal. But we're going to square x plus 7. Oops, 7. And then subtract 6 and multiply by 4. So this is x squared plus 7x plus 7x plus 49. Times 4 minus 6. So 7x plus 7x is 14x. So this is x squared plus 14x plus 49 times 4 minus 6. So this is now 4x squared. 14 times 4 is 56. X and 49 times 4 is 200 minus 16. So 184, don't quote me on that. 186, I need Desmos. 4 times 49, 196. No, it ended in a 6. Plus 196, and then minus 6 becomes 4x squared plus 56x plus 190. Let me double check my math for 14 times 4. I think that's correct. It is.